This is section 6.1 of Precalculus. It's the beginning of the second semester with the trig information. So first thing, we have to start with several definitions related to trigonometry because we're going to go back to before what you even learned in geometry related to sine, cosine, and tangent. This is kind of developing all the different trig functions. So the first thing you need to know is that an angle is defined as a rotation. So in trig, you don't just look at something and see an angle like you did in geometry, but it's actually a rotation of two sides. So for example, let's just write down here that it's defined as a rotation. Okay, an angle is defined as a rotation, and the way it works is you have an initial side, which is always laying right here on the positive side of the x-axis. So there's the initial side. So let's put here on positive x-axis. And then you have a terminal side. Terminal side. So the initial side is laying on the positive x-axis, and then you have the terminal side, which starts off right here at the same place, but then that terminal side will start to rotate, and if it rotates this direction, so let's say it rotates and lands right there, then we would say that that's a positive angle. So the terminal side is the side that rotates. Okay, if that terminal side were to rotate in the other direction, let's say this direction, so it started right here on that positive x-axis, but it rotates this direction, and let's say it lands down here, then we would say that that's a negative angle. So this is negative, where when it rotated up this direction, this was positive. Now, I'm not saying this is the exact angle measure, but maybe this one rotated about halfway up in that first quadrant, so we would say that's maybe 45 degrees. Whereas if it rotated the same amount, but in the opposite direction down here into the fourth quadrant, we would say that's like a negative 45 degrees. So in trig, you can have positive and negative angles, and it all depends on the direction that your terminal side rotates. So all of this together is what we call standard position. So standard position is where the initial side, let me do this, all of this together is what we call standard position. So it's laying on the xy axis. The first side, the initial side, is on the positive x-axis. The terminal side is the one that rotates. And then the vertex is just like you're always used to. The vertex is what is that point right there at 0, 0. That would be the vertex of the angle if this angle is in standard position. Okay, so we talked about negative angles, but let's actually write this down. So negative angles is if the angle rotates, and I'm going to say rotates down, but most textbooks would say that is a clockwise direction, right? Because if you think about it, the hands on a clock tick around this direction, right? From 1 to 2 to 3 to 4 to 5 to 6 and on around, okay? Whereas textbooks would say if it's a positive angle, it's going to rotate in the counterclockwise, so the opposite direction that the hands on a clock would rotate. But for most of us, it's easier to just think rotating up versus rotating down. Okay, one last definition before we move along to kind of drawing some of these, and that is coterminal angles. So let's break apart the word. Co means same. Terminal, well, we talked about that's the terminal side. So coterminal angles are angles that have the same terminal side. Same terminal side. So let's say, for example, maybe we just talk about a 30-degree angle. All right, well, a 30-degree angle, so here's the initial side. If I rotate 30 degrees, and I'm not saying this is drawn to scale, so if that's a 30-degree angle, a coterminal angle might be, what if we have an angle that rotates the other direction, but it lands right there on that same side, but because it rotated in a negative direction, that one would be a negative 330. So would you agree that a negative 330 and a positive 30 are going to land right there at that same terminal side? So we would say a negative 330 and a 30 are coterminal angles. Now, in order to have coterminal angles, you don't have to have a positive and a negative. Let's take another example. Let's say I have, I don't know, I'll say a 100-degree angle. So if I have a 100-degree angle, here's my initial side. 100 degrees would mean I'm going out of the first quadrant, just barely into the second quadrant. All right, so this would be a 100-degree angle. Well, let's say I have another angle, and it's not going to go in a negative direction, but it still starts right here. But let's say it goes, that my side rotates all the way around, so now I'm at 360, and then I go another 100, so now I'm at a total of 460. So a 100-degree angle and a 460-degree angle both land at that same place right here as this terminal side, and we would say a 460 and a 100 are coterminal angles. Okay, so let's do a lot of drawing pictures here, because that's really what this 6.1 is all about. So sketch each angle in standard position. So 100 degrees, well, we just did that. Here's my initial side. If I rotate 100 degrees, I'm going to come past the 90-degree mark right here to 100. And it's important when you're drawing angles that you show this arrow right here, because it represents the rotation. If I just were to draw the angle, if I don't have this arrow, if I just draw that, I don't know which direction that angle rotated. Did it rotate in the positive direction, or did it rotate in the negative direction? It might be significant right here, before we kind of move along, to think about, you can rotate as many times as you want to. If this is my XY axis, and I'm right here, so if I'm going in the positive direction, right, up here would be 90, keep going, over here would be 180. If I keep going, this would be another 90 degrees, right, so 270, and if I keep going all the way over here, even though this was 0, it's also, if you're rotating all the way around, it's also 360. Whereas if you had rotated in the negative direction, you would still start here at 0, but if you came down this direction, you'd be at negative 90. If you keep going over here, you'd be at negative 180. And if you keep going up here, you'd be at negative 270. And if you keep going all the way around, you'd be at negative 360. So remember, each quadrant is 90 degrees, but it all depends on which direction you're rotating. Okay, back to drawing more practice ones. Number 2, 250 degrees. Well, that means here I am. I start right here in the positive x-axis. Remember, all the way down here is 270, so I'm going to fall just short of that right there. Might be 250, and they don't have to be perfect. You just have to get them in the right quadrant. Show the angle of rotation, show that arrow to represent which direction it rotated, and then label it. Okay, what about a 370? So here I am starting on the positive x-axis. If I can get my pen to work. All right. So I'm right here on the positive x-axis, and if I go 370, remember, one full circle is 360, and then I'm going to go another 10 degrees, so just a little bit more, and that would be my 370. Okay, so what if I want to go negative 150? Now don't forget, you still always want to show where you start. So here I am, my initial side, and if I go negative 150, so if I go halfway around, that's going to be negative 180. So I'm going to fall right in here, and that's going to be my negative 150. So if I go negative 30, there's my initial side. So 30 degrees would just be a little bit in the negative direction. So negative 30. And then negative 400. So here's my initial side. So all the way around to here is negative 360, and then I need to go another 40. So negative 400. So again, how exact do you have to be? Well, get it in the right quadrant and then show the angle of rotation, and then just label it. Okay, so letter B. Determine the quadrant in which the terminal side lies. Sketch the graph if necessary. Well, again, keep in mind what we said a minute ago. 0, every quadrant has 90 degrees. So you really don't have to draw it to know which quadrant it lands in. If I'm going 50 degrees, I'm still in the first quadrant, right? If I'm going 335, well, I'm going past the 270, but not quite to the 360, so aren't I going to land right down there in the fourth quadrant? So determine the quadrant in which the terminal side lies. The terminal side is going to land in the fourth quadrant. What about 181? Well, it's going to go just past the 180, so it's going to land in the third quadrant. Negative 200, okay, let's kind of draw it out. So here we are at negative 180, and if I need to go another 20, aren't I going to land right up there in the second quadrant? So even though it spans across in 3 quadrants, that still is labeled as the second quadrant. And I guess maybe I should have done this at the beginning. We are all in agreement, right, that as far as quadrants are labeled, you have first, second, third, fourth. And I always label them using Roman numerals just because that's how quadrants are really supposed to be labeled. I know some teachers have switched over and don't use those, but that's really how you're supposed to label quadrants. Okay, what about number 5 if I have a negative 280? So here's where I'm starting. So negative 180. Remember, if I go all the way up to here, I'm at negative 270, and then I need to just go another 10. So I'm going to actually land in the first quadrant. Negative 80 means I'm not going to quite go down there to the y-axis, so I'm just going to fall short, and so I'm in the fourth quadrant. Okay, determine 2 coterminal angles, one positive and one negative for each angle given. Okay, so we're not including 100 as the positive angle. So again, you don't have to draw it, but this is just something for us to think about. So if I have a 100, that means I'm rotating right over here into the second quadrant. Okay, one possible coterminal is if I had gone in the negative direction. Well, if I went in the negative direction and I still wanted to land right there, wouldn't that be a negative 260, right? Because a full circle is 360. So how did I know negative 260? Well, because I'm taking off that 100, so it's only negative 260. But the directions say give one positive and one negative. Okay, so negative 260 would be coterminal with 100. But what would be another another positive angle that would land over there at the 100 mark? So in other words, if I started here, I went around one full time, that's 360, and then an additional 100, wouldn't that be a 460? So you can picture what's going on. So one possible coterminal is 460, one possible coterminal to the 100 is negative 260, but you really don't have to draw it out, because if I want to land at the same place, wouldn't that mean that from that spot, so let me go back to showing you the picture. Here I was at my initial 100 degree spot, right here. There's my where I want to land. If I want to land at that same spot, then from that point, from that 100 point, I can either go one full circle in the positive direction from that point, Or I could go one full circle in the negative direction from that point. But if I go one full circle from that point, it's still going to land at that same terminal side. So really what I'm doing is I'm saying, hey, if I go one full circle in the positive direction, aren't I just adding 360? So 370 would be a possible coterminal. But if I'm going one full circle in the negative direction, that means if I start at 10 and I go in the negative direction, a full circle, then wouldn't that one take me to negative 350? So really, to find coterminal angles, you don't have to draw it out. You either just add a full circle, so add 360, or you subtract a full circle, so subtract 360. So let's try that method here for number 3. If I have a 40 degree, if I add a full circle, that's going to take me to 400, so that's one possible answer. If I subtract 360 from that 40, that's going to take me to negative 320, so that would be another possible coterminal angle if my starting point is that 40 degree mark. Okay, so that's section 6.1.